Today we are going to discuss a question related to vertical circular motion. So the question is, a small bead is placed on top of a frictionless glass sphere of diameter d. So the diagram is like this. So we have a glass sphere which is placed on a horizontal surface, and a small bead is kept at the top of the glass sphere. The bead is given a slight push. You are giving a very slight push. So this glass is fixed and you are keeping a very small bead on top and you are giving a little push. Slight push and start sliding along the sphere. So this one will be falling along the sphere. Find the speed v of the bead at the point at which the bead leaves the sphere. So you all know, if you physically think about this bead, what will happen is, so it will first move down like this. So what do you think? Will it go like this until it touches the ground? Is it physically happening? No, it is not. It is not practical. So if you think about this one physically and practically, you will see that this one will leave the surface somewhere here and it will follow a projectile path like this. So this is what actually is happening. So we see at some point like here, we can see that this is leaving the surface. The contact between the surface, contact between the spherical surface is lost here at this point. So that is the point that we need to analyze. So it is said that velocity is v at this point. So you have to calculate this one. So diameter of the sphere is given, that is capital D, and we have no any other clue given, so only given is this data. So we'll assume that this is the point where this one will leave the surface. So if you mark forces acting on this one, because you know this is a vertical circular motion, so there are two steps to solve the circular motion question. So the first step for a vertical circular motion is to apply F equals ma towards center, where acceleration is the centripetal acceleration. And the second step is to apply law of conservation of energy. So we have two instances. First instance is here and the second instance is here. Then we can apply law of conservation of energy to this point and this point separately. Right. So that's the first step. We have to apply F equals ma. To apply F equals ma, you need to know the forces acting on this one. So first we will mark what are the forces acting on this bead. So you know weight is there, that is compulsory, mg is there, and there's a contact. So we will assume still this is in contact with the surface of the sphere. So we know that there's a perpendicular reaction force that P will say R. So if you extend this one, as this is perpendicular to a circular surface, it must be passing through the center of the sphere. That is basic geometry. Right. So this will be perpendicular to this one. So these are the forces. The reaction force is in the perpendicular direction out from the center, and we have weight acting downwards, and we will say the angle between the weight and the vertical, sorry, with the dotted line and the vertical, that is theta. We will assume this angle is theta. Here it is theta. So we will have to use this theta in our calculation. So just an assumption, right? So we have marked all the data that we require. So let's follow the steps. So first step is to apply F equals ma towards center. So we will say, I will say this is point P and I will say this is point Q. So I am applying F equals ma towards center for point Q, right? At point Q I am applying F equals ma towards center such that A is equal to R omega squared or V squared over R. So from theory you know that this is the centripetal acceleration, right? Now we will apply. So this is the center of the moving circle. So what are the forces acting towards center? So one force is you can take component from the weight to this side. This is the center, so you have to take a component like this. That will be mg cos theta, because you are taking the component towards the angle. So that will be mg cos theta. And you know that R force is also acting on this bead, and it is acting away from the center. So you have to put it minus. That is equal to, so we have assumed that velocity is v, and we will say mass is m, right? Assume mass is m, is equal to m v squared over r. So the radius of this one will be d over 2 now. So this is our first expression. So this is our expression by applying F equals mv, right? Now what we can do is, we know that at this point this one will leave the surface. So what will happen if it leaves the surface? So at the point where the contact is losing, this reaction force goes to 0. So then what we have to do is, we can take the logic that when this bead leaves the surface of the sphere, R goes to 0. That is very crucial, because there is no contact between sphere and the bead when it leaves the surface. So the only way the reaction force can happen is with the contact. When there is no contact, no reaction force. So you can apply R equals to 0. So when you apply R equals 0 condition here, you can take mg cos theta is equal to mv square over d over 2. So I can put it like this way. So here you can cancel out m, and you can get an equation for v square. So we have v square is equal to g d cos theta divided by 2. So this is the equation for v square. But the problem is, we do not have data regarding theta. So it is not a given data. So we have to calculate theta again by using some other kind of equation. So for that one, I can apply law of conservation of energy. So I will apply law of conservation of energy to P and Q. Right? Okay. So we will see how to apply. So for that one, we know in here it only has potential energy. Here it has both potential energy and kinetic energy. If you say that this is your E0 level. So when you take E0 level here, it is difficult because you have two kinds of energies here. So the trick that you can do is, you can take your E0 level from this height. So we will say this is our datum, or the E0 level. Potential energy 0 level. If you take our datum line or the E0 level here, then this one has only kinetic energy. It does not have any potential energy. Here this one has only potential energy, no kinetic energy. So whole thing is now very simplified for us. Now we will apply law of conservation of energy to P and Q. So total energy at P, that is potential energy. So you have to write mg times the vertical height. So the vertical height from E0 level is this small length. Right? This is the length. How do we find this one? So we know that from this point to this point, that is the radius of the sphere. From here to here the radius. And here, this line is also representing what? This is also a radius, because this bead is located on the surface of the sphere. So then if you consider this right angle triangle with this angle here, this right angle triangle, this length will be r cos theta. So you can write this one as r cos theta. So this is basically r cos theta. Right? Up to here it is r cos theta. Right. Then this small height, if I label that one as h, that h height will be r minus r cos theta. Very simple. Hope you get it correctly. This total length is r, and this what is r cos theta, because this is r. When you take the reserved component of this length from this right angle triangle, this is r cos theta, and the h height will be r minus r cos theta, and that is equal to half m v squared. Now very easily we can simplify. Here you have m, and you can simplify. You can take out r. So gr 1 minus cos theta is equal to v squared over 2. Right. So we have to find v squared. Then we can easily find cos theta, and you can apply it here. So we will apply easily. So you can take 1 minus cos theta is equal to v squared over 2. This r means actually the radius. So I have to take that one as d over 2. Right? 2g d over 2. That is the radius of that one. Right? Here 2 cancels out. Here I get 1 minus cos theta is equal to v squared over gd. Right? Okay. Now what you can do is, we have two equations. So you can subject cos theta from here or here, and you can apply here. So I will take it from here. So that will be cos theta will be 1 minus v squared over gd. Right? Okay. Now I can apply it here. So apply it here. That is v squared is equal to gd over 2 times 1 minus v squared over gd. So you can expand the bracket. V squared is equal to gd divided by 2 minus, here gd cancels out, v squared over 2. When you take this one to this side, it will become 3v squared over 2 is equal to 2, here it becomes g capital D over 2. Then this one will get cancels out. Then you can get, I will write it from here, that is v squared is equal to gd over 3. Now v will be gd over 3 square root. So this is our final answer. So you may have different simplifications methods for this one, but your basic steps are the same. So first thing is, you have to apply apply f equals ma towards center. That is a must. Then you should make your contact point 0. That means your reaction goes to 0. That is also a must. Then you have to apply law of conservation of energy. So your simplifications methods may be different. So this may be a longer method for you, but you can find a very simple method. That is no issue. The fine thing is, you have to get the final answer correctly, but make sure you follow the shortest method. So you can use different simplifications method, and you can try. You can take cos theta from here, and then you can plug in here, or you can try to simplify it from here. Please do those experiments. Try to find a shorter method. Then no one is required for you to teach the shortest method. You try different ways and identify what is the shortest method for this question. So you can do this for each and every question that you come across. So I hope this question is very clear to you. So we will meet in another video like this. So one request from you, that is, if you have any difficult question that should be discussed in detail, so let me know. So you can contact me through the phone number I have given. You can contact me through WhatsApp, or you can give a comment on that one on our video. Then we can discuss difficult questions that we have. So thank you very much for watching. Okay, see you in another video. Thank you.